So this is backwards. Gave you the equation, gave you the graph, write the equation. So this is what the graph looks like. You can even picture it. You know there's two roots, and you know instead of a minimum, there's a maximum. So it's going to be a parabola that looks like this, right? So you know what the original looks like. There's two roots, and look, there's one minimum, which becomes a maximum. So you know in your head, you're thinking, oh, it's a parabola that looks like that. Let's get the equation of that parabola. Okay, so we've got f of x equals. Now, the easiest way to do this equation is to use the two roots. My roots are going to be at x equals -3 and 3, right? So I'm going to use the roots. I think that's one of the easiest way to look at that. So I'm going to use the roots. So I know it's going to be x plus 3, x minus 3. So I know that my factored form of my quadratic will look like that. However, you have to put the a in front. Just like when we did the polynomial equations, you don't know what the stretch or the shrink is, right? So you have to do a in front, but I know the two factors are there. How do I get the a value? I need a point. Any point that would be on, not here, but on my original graph, on the quadratic. Not this. A lot of people go and say, oh, can I use 0, 4? No. 0, 4 is on the reciprocal. I want a point here. But, yeah, what do you think?
Can you just use 1, 1 every time?
No.
Okay, like negative
No 1, 1. No 1, 1, because I don't know that there's no stretch. What can I use? What do I know? Yeah. The maximum. I know this is a minimum, so again, translate it. So here, translation, I know the minimum is at 0, 4. True? That translates to, on this graph, my max at 0, 1/4. Does that make sense? So last time we were translating this onto my reciprocal function. Now we're going back. So if you know it's a minimum, so that max min point is super important because it can translate back and forth. So if it's a minimum here, it's a maximum here. We're going to plug this in here. So this is x and y. We're going to plug that in for x and y. Does that make sense? Sorry, you can't see the pink. So x and y. So this y would be the 1/4 equals, and we're going to find the a. So we're trying to find a. And then my x is 0. So 0 plus 3 and 0 minus 3. Gorgeous, yes.
Could you also use the invariant points?
Could you also use what, sorry?
The invariant points?
Yes, as long as I give you, that was not clear. See how bad my graph is, though? When you look at this and you go, wait, are you sure that's an invariant point? You have to make sure I dotted it, honestly. So the question is, can you use one of the invariant points? Yes, you can, but I was actually, and not on purpose, I was sloppy. So I'm not sure if I actually want it to go through this point or that point. So try to use a point that's for sure. If I don't, so yes, the answer is you can use the invariant point, but make sure I dotted it, okay? Or it has to be by computer. If it's on the computer, then you can look for the invariant point. If I did it by hand, if I put a dot on it, I'm saying, yes, it's usable. If I didn't, look at this, it's not good, right? Because I drew it by hand and I wasn't being super careful. So what I end up doing, look at this next one, I put dots. So I'm saying, yeah, that's perfectly good. If not, the vertex for sure was at 4, right? So just be careful because if I'm doing it by hand, you have to say, did she give me a signal that that's a good point, or is she kind of a little sloppy with the hand? Computer, yes, if I do it on a computer, you can use whatever looks solidly there. Yeah. Okay, so yes, the answer is you can use invariant point as well. So that one's good. Invariant points are good. My invariant points were a bit meh, so don't use those. Okay, and here we go. So this will be 1/4 equals a, 3 and 3, so -9. How do you divide both sides by 9? So divide it by -9. So that would be, so if you forget how it's 1/4 divided by -9, which changes to multiplied by 1 over -9. Do you remember that, the reciprocal? Okay, so that cancels, so it's a. So division by that means multiplication by the reciprocal, so this becomes -1 over 36. So therefore, f of x equals negative 1 over 36 x plus 3. And you can leave it in factored form. You can leave that in factored form. Okay. We're going to try that again. We're going to try that again, except with this one. This is the one we just did. On the other page, there are no roots. So that means I cannot use this factored form because there's no two factors. There's no two roots. So it's exactly this one that we did on this page where I said, oh yeah, but what happens if there's no roots? So that's telling me that the parabola is either above or below the axis. There's no roots, right? So here, there's no roots. So in my head I went, uh-oh, this is the one with no roots. Right? There's no roots. That's what that graph is telling you. So if there's no roots, then I cannot use this factored form. I want you to use, so that tells me I want you to use vertex form. You don't have to write that, but that's what it tells me to say, oh, okay, so then if there's no roots, I can't use factored form. If there's roots, factored form is glorious. Okay? If there's no roots, I got to go to vertex form. So what I'm going to do is I'm going to say, okay, I know vertex form. That's f of x equals, it's a x minus, I don't know if p or q, what value you use, plus q or h and k, whichever values you do there. So I need this form. Because, again, there's no roots, so I can't use the two factors, but I can use the max min. So we're going backwards, right? We're looking for invariant points, but the invariant points, look, I didn't dot them, so don't use them. If I don't dot them, it means that my hand-drawn diagram might not be great. If it's on the computer, you can, but here I put the dots there, so you can use those points, but don't use those other points, okay? So if I don't dot it, please don't use it. Then you're going to go, okay, so I can use the max, which is now a min. So on this one, I know the max is at negative 4, 3. Does that make sense? Negative 4, 3, which converts to a min at negative 4, 1/3. Does that make sense? So this max converts to a minimum here. So that gives me, the minimum gives me the vertex. And sub that in. Okay, so we're going to sub that in. So we're going to say equals, I don't have A, so we're going to still find that in a minute, right, when I sub something in. So we'll find A in a second. Don't worry about the negative positive. I just want the vertex. So it's going to be x plus 4. Is that okay? Opposite, so plus 4 squared plus 1/3. Okay. Then I'm going to sub in a point. So sub a point to find A. Okay. So what point can I sub in?
What are the points you gave us on the right or left of the table?
Yes. And so what point is that going to be? So when I sub that in, take one of the points.
Negative 3, 1 over 2.
-3, 1/2. Yes. Right? So this point here, so if I take this point here, I'll do -3, and it's 1/2. Does that make sense? So take it, convert it, and bring it over here. Okay, so convert it. So it's all this conversion back and forth. So it's -3, 1/2. Let's sub that in. So that will get me, I'm going to get 1/2 goes here, equals, and we're still solving for A, so I'll highlight that one more time. And this will be x is -3 plus 4 squared plus 1/3. And this will be 1/2 equals A. That's 1 squared, so it's still just 1. Plus 1/3. So this will be 1/2 minus 1/3 equals A. Does that make sense? And I'll do lowest common. So times 3 times 2. You don't have to show this. I know you can do it in your head. 3 minus 2, so it'll be 1/6 equals A. So therefore, and then my conclusion, f at x equals 1/6 x plus 4 squared plus 1/3. And you can leave it in vertex form. Done, done, done. Gorgeous, gorgeous, gorgeous. Okay, last one. For this section here, we are just doing exactly the same thing. So if you see that there's two vertical asymptotes, sorry. If you see there's two vertical asymptotes, that means there's two roots, right? It hits the x-axis twice. That means it's going to be the factored form. So go right ahead and use factored form. I was just trying to show you the contrast between this form and the other form. So we have, right? If I give you something like this, you can't use the factored form because there's no two factors. If I give you something like this, then for sure use the factored form. So you're going to go f of x equals, we're looking for a, and your two roots are 2 and 6. So x equals 2 and 6. So x minus 2, x minus 6. Okay, we need to find a. So sub in a point. So right here, I like my see how it's dotted? It's calling to you, saying, look at me, use this. So my max is going to be using the point 4, -1 converts. So this is a max, converts to be my minimum of 4, -1. So there you go. So that was the invariant point you were talking about, yes, and I was going to show that, so exactly. So it's invariant point, it'll be on both, right? So it'll be in both because it's an invariant point. Isn't that cool? There you go. And then plug that in, and we just solved. So this was a straightforward one, just showing you the contrast of the two. So -1 equals A, 4 minus 2, 4 minus 6. So that's 2, -2. And that's -4a. Divide both sides. Okay, and then this will go to 1/4 equals a, so therefore f of x equals 1/4 x minus 2, x minus 6. So it's just showing you the contrast of the two types. If you have the roots, use the factored form. If you don't have the roots, then use the other form. All right?